All right, so we're on page 85, right? Everybody's on 85? Okay. Tiara, will you read this first box for us, please?
Perform arithmetic operations by polynomials. Understand the polynomial form, a system of integers that are polyfunctions, operations of addition, subtraction, and multiplication.
All right, so we are going to be creating and forming new polynomials, okay? In our bell work, did we do all three of those? We did addition, we did subtraction, and we did multiplication, okay? So then our statements are, I can form and simplify polynomials by using addition, subtraction, multiplication, and I can take a polynomial and determine what operation to use when simplifying. So by the end of class today, we need to be confident in adding, subtracting, and multiplying polynomials. Okay? Then probably Monday, you'll create your own and simplify them from there. Okay? All right, so first, on number 1, it says, what is the form of a polynomial? All right, so you know what a polynomial is. You may just not know that that's what it is. Okay? So, I want you to write on number 1, f of x, which means y equals a n times x to the n plus a n minus 1 times x to the n minus 1 plus dot a to the 1 times x plus a 0. Now, do you have to remember that? No, not at all. Okay? But this is what a polynomial looks like when there are no numbers and letters involved. Okay? Just generic, plain form. What do you think those little dots, 3 dots mean? It just keeps going. Okay? So I also want you to add n equals non-negative integer. And the n that we are referring to right here is the n in the exponent. In these 3 topics, we're going to refer to exponents as the power and a degree. So when I say x to the 2nd power, that's x raised to what exponent? 2 squared. Yeah. If I say this is a 3rd degree polynomial, the highest exponent is what? 3. Okay? All right. Then I want you to draw an arrow that's pointing to the A0. And I want you to write coefficient is a real number. So that goes to not only the A0 that we have drawn the arrow to, but it also goes to this AN minus 1, A1, and A0. So what is the coefficient? Is that the number or is that the letter? That's the number, okay? What is another word for the letter? It starts with a V. Variable. Okay? So you need to remember those. Coefficient is a number. Variable is a letter. Okay? Now, what do you notice? The A0 does not have attached. It doesn't have anything to multiply by. It doesn't have a multiplication sign. It doesn't have an X, and it doesn't have the power, the exponent. Okay? That is because that is a constant. What is a constant? Well, that's what constant means, yes, but constants just hang out the end. Do they have anything attached? No, they're just a number, okay? Those always come last. So this is a general form of a polynomial, okay? Now, you don't have to write this down, but y equals 3x squared plus 4x minus 2. Is that a polynomial? Yep. Y equals 3x minus 7. Is that a polynomial? What exponent, what power is on that x we don't have to write? Now, is it a polynomial? Is y equals 7 a polynomial? Alright, so now we said the first two are polynomials and the last one's not. The first two, they all obviously include numbers. They also include what? Variables. And they also include exponents. So this right here, the first one, is what degree polynomial? What's the highest exponent? So this is a second degree. What about the second one? It is a first degree. Now, are you ever going to see that 1 on that x? Nope. But you know it's there. Just like if I wrote y equals x. What number's in front of that x? 1. Okay. Now, y equals 7. And that's not 7x. That's like x is not it. Okay. So y equals 7. It has a number. Does it have a letter attached? It has an exponent, I guess. But is it going to change my number? What is 7 to the 1 power? 7. What if I put 7 squared? I still get a what? I still get a number. I never require a letter in there. Okay? So, look at number 2. All right, it says, consider the quadratic function h of t, which is just really fancy for what? Y equals negative 16t squared plus 150t plus 5. All right, the first part of the question says, what degree, or what is the degree of this polynomial function? It's a second degree. All right, so we remember what this is. I want us to write on number 2. Largest exponent equals the degree. So even if the highest power is not the first term you see, You still got to look for the highest one. Okay, and you'll see that in a minute. So this is a second degree. It's what you just said because it has this. Then it says, what is the leading coefficient? First of all, what's the word leading mean? It's going to be what? Okay, and what's the coefficient? A number. All right, so somewhere else, jot this down. Leading coefficient equals number with the degree. So what number is with our degree? Negative 16. Be sure to include your sign. LC stands for leading coefficient, by the way. At the bottom. Then, it says, what is the constant term? What is the constant? It has nothing attached, all by itself. 5. So we've got a second degree polynomial. Because it has a square. The leading coefficient is what is attached. So negative 16. Constant has nothing attached. Okay? Questions? All right, number 3. Down here at the bottom it says, you know that a linear function can be expressed as slope-intercept form. Y equals mx plus b. Where m is the slope and b is the y-intercept. Can a linear function be considered a polynomial function? Why, Tiara? I have a number, and I have a letter, and I also have a what? I also have an exponent, a power. What is the exponent on that? What is the exponent? 1. So, it has a number, it has a letter, and power of 1. So if it has a power of 1, it is a what degree polynomial? Yep, first degree. Good. All right, now, number 4. Simplify the polynomial addition problem. So we're going to do one together. You're going to do B by yourself, okay? So, number 1 says 7x squared minus 14x plus 25 plus 3x squared plus 3x minus 4. All right, Kyler, can I rewrite this without my parentheses and not change anything? Yep. Now, you don't have to do this step. I do this step because when you do have to change something for when you're subtracting, you have to rewrite it anyways. So I just go ahead and do it for addition. That way I'm doing the same thing every time. Okay? All right, now, keep in mind, the correct way to write a polynomial is to always start with your degree, your highest power. Now, a lot of times you'll see it written the opposite because they're trying to trick you. Okay? But you have to know highest power always comes first. All right? So what is the highest power you see, Caesar? Square. Good. All right, so we got a 7x squared and a positive 3x squared. 7 plus 3 is what, Callie? 10. So we got 10x squared. I'll mark them out so I know they're done. Okay? All right, then we have a negative 14x and a negative 3x. Negative 14 minus 3 is what, Ann? 11x. Negative 11x, good. And then we have 25 and negative 4. 25 minus 4 is what, Bonnie? 21, good. Okay? Now, you take 1 minute and do B. Go. You're right. Well, let me make it bigger. All right, B was 3x squared minus x plus 2 plus 16 minus x squared. All right, can I rewrite this and not change anything? Yep. 3x squared minus x plus 2 plus 16 minus x squared. All right, what's the highest power you see, Lee?
16.
Not the highest number, the highest power. All right, good. So we got 3x squared and a negative x squared. 3 minus 1 is what, Kyler?
2.
2. Woo. 2x squared. All right, then, do we have any other x's besides that one negative x? So what do we do with it? We just drop it down. We got 2 constants, positive 2 and a positive 16, which is what?
18.
Yep. Everybody get that? Everybody's I looked at had that. Good. All right. Flip over. Now, it says, when calculating the square footage of a house for resale, real estate agents do not figure in any area that is not heated or cooled, such as garages, patios, or covered porches. Suppose the total square footage of a house is represented by the expression 35x squared plus 20x minus 56. But this expression includes the garage space of 2x squared minus x plus 21. What square footage would the real estate agent list on the house appraisal sheet? All right, what did they first tell us? Real estate agents do not include what? Areas that don't include heating and air. Okay? And they gave some examples. Garages, patios, covered porches. Well, this person, they got a garage. So if our total is at 35x squared, and our garage is at 2x squared, what do we need to do? We need to subtract because we don't want to include the what? We don't want to include the garage, the 2x squared. All right, so first we have 35x squared plus 20x minus 56. That is my total, right? Minus 2x squared minus x plus 21. Now, when I rewrite this, and I take away my parentheses, what happens to all the signs on the right? They change. We have to distribute the negative, okay? So we can write the first one with no problem. Okay? This first one's going to say positive 2x squared or negative 2x squared. All right, so we got negative 2x squared. Then the next one, there's already negative there, and we know two negatives make a positive. And then if we do the last one, we know a negative trumps a positive, so it becomes negative. Now, we combine like terms, whether it's adding or subtracting, we combine them. Highest exponent is 35. So we got 35 minus 2, which is 33. And we got 20x and another x, which is 21x. And we got negative 56 minus 21, which is negative 77. And that's going to be feet squared. Now, this is not really about polynomials, but why is it feet squared? It's the square footage. How do you find the square footage of something? It's the area of your, it's the area of your house or your garage or whatever you're doing. Okay? All right. Y'all think you can do number 6 on your own? Yeah? All right, let's take 3 minutes and do 6A and 6B. All right, 6A was 4x cubed minus x squared, 5x minus 9 minus 5x squared minus 8x minus 7. All right, did you change anything in the first set of parentheses? Nope. Then, what'd you make the 5? You made it negative, and everything else needed to change to be, yep. All right, do we have another 4x cubed or another x cubed anywhere? Nope, let's just bring it down. All right, then negative x squared and negative 5x squared, which makes a negative 6x squared, good. And then a positive 5x and a positive 8x, which is 13x, good. And then we got a negative 9 plus 7, which only leaves us with, raise your hand if you got that. Good. Almost everybody. It's a plus. All right. Next. We're adding on this one. So does any sign have to change? Nope. Do we have another x cubed? Nope. All right, then we go to an x squared. I have a negative 5 and a positive 5. So what happens with those? They just cancel out. So do we even have to write that? No. If it's missing, you won't ever... No. I won't say you can't write it. I mean, you can say 0x squared. But will you see it that way? No. It'll just not be there. Okay? All right, then we go from a 5x to a negative 9x, which leaves us with, yep, a negative 4x. And then a negative 2 minus another 7 is a negative. How many of you got that one? Good. All right. Let's see. There's 6. And they show you the answers too. Oh no, not that. We don't want to go to that. Not that either. Oh, not that either. All right, number 7. It's kind of like what we answered on number 3, I guess. When we add polynomial expressions together, which is what we did on 6b and before, okay? Will the sum always be a polynomial expression? Yes, because what are we actually doing? We're just simplifying it. We're not changing the x squared or anything, okay? Then it says when you subtract, will it always be 1? Yep. Yep. You're just simplifying. Okay. All right, now, number 8. It says, find the product. What's the word product mean? Multiply. Okay, now, remember I told you I teach it the box method. If you're not a fan of the box method, you can do that rainbow foil method. Okay, I just do this because I think it's easier to see. Okay, so draw your box. A 2x2. 3x minus 2 and 2x plus 2. Now, does it matter which one you put on either side? Nope. So multiplication is commutative. So the order does not matter. Okay? So, the first two, 3x and a 2x, match right here in this top left box. So 3 times 2 is 6. X times x is x squared. Alright. Negative 2 and 2x, if you meet them, they end up in top right. So that's going to be a negative 4 what? Negative 4x. In the bottom left, 3x matches with 2. So that's going to be a 6x. Good. And then the last two, a negative 2 and a positive 2, make a negative 4. Now, we multiply on the outside and combine on the inside. Okay? So do we have another x squared? Nope. So x squared, we've used it. We combine these because they're the same. 6 minus 4 is? Do we have another constant? Nope. On the next page, page 87, let's take 4 minutes and do 9A, B, and C. All right. First one. It had both what in it? What operation? Adding and subtracting. Okay. So, could you rewrite the first two parentheses and not change anything? All right, so we got 2x minus 3 plus 3x plus 12. Now, that 4 became what? It became negative, and the 6x became what? Positive. And now you just combine like terms like normal. So a 2x and a 3x and a 6x make an 11x. And then we got a negative 3 plus 12 minus 4 leaves us with positive 5. Did we get that? Good. All right, the next one was just adding. Just combining like terms, okay? Jacob, what did you get for 9b?
X cubed minus 4x squared plus 7x minus 6.
Not minus 6, minus what?
1.
Minus 1. That's 6, negative 6 plus 5. So that first 5. Second set of parentheses.
Oh, yeah.
How many of you got 9b right? Good. All right, 9c should have been x squared plus 3x minus 6. Yes? All right, now let's take 3 minutes and do 10A and 10B. And then before you start, look at C and D. They have how many? They have 3. All right, so let's do the ones we know first. 10A and 10B, and then we'll move to C where we add another one. Got it? All right. 10A. Got us a nice little box. X plus 2. X minus 6. X times X. X squared. Then top right, you got what? Top right. Yours might be different than mine. And then you got negative 6x, and then what in the bottom? Negative 12. X squared. Combine these and get, yep, negative 4x minus 12. Yes, no, maybe. Yes? No? All right, let's look at the next one. It's a little bit different, but same concept. All right, and what did you put at the top of this box? All right, x squared minus 4. Some of you might have put x minus 6, which is fine. On the right, or the left side, we got x minus 6. All right, Dylan, what is x squared times x?
X cubed.
It's an x cubed. All right, then we have a negative 4 and an x, which is a negative 4x, and then a negative 6, and an x squared is a negative 6x squared, and a negative 4 and a negative 6 is a positive 24. Now, do you have anything you can combine? Nope, but we always write it with what being first? The highest power, highest degree. So you should have x cubed minus 6x squared minus 4x plus 24. Yes? Better? No? Okay. All right. On C, you see three things, right? What I want you to do right now is multiply the first two and then stop.
What, like normal?
Just normal. Yeah, just pretend the third one's not even there. Just do the first two. Alright, when you do the first two, you got an x plus 1 and an x minus 1. X squared, x, negative x, negative 1. Yes? Alright, what happens to these two x's? They cancel out. So what am I left with?
X squared.
Alright, I'm left with x squared minus 1. So that is my product from the first two. I take that product and I do it again, except I multiply by the third one. So you're doing the same thing. The product was x squared minus 1 and x plus 3. So simplify that. What's x squared times x? X cubed. Good. All right, and then let's do x squared times 3. 3x squared. Good. And then x times negative 1 is negative x. Negative 1 times 3 is negative 3. Now, is there anything I can combine? No. Highest power first. I can't see that. Hold on. So that is my solution, my product of all three polynomials. Okay? So I started with 3 first degree polynomials. Does everybody agree? There's 3 of them and they're all first degree. And I ended with 1, what degree? Third degree. Okay? Now, a few minutes ago I said that multiplication was commutative, which means the order does not matter. Okay? I just do it because that's the order it goes. The first 2 and then the third one. However, if for some reason you want to do it the other way, you can do the last 2 and then multiply by the first one. Or you can do the first and third and then do the product with the second one. In the end, the answer is all going to be the same. Okay? Got it? All right. Let's do D together because D's going to come out different. Yeah, you figured that out? Do you know how to solve it though? All right. So we've got the first 2. All right, Bonnie, what is x times x? X squared, good. Lee, what is 2 times x? 2x. Jalen, what is x times negative 1? What kind of x? Positive or negative? Negative. Caesar, 2 times negative 1. Negative 2. All right. Now, we can combine, right? These right here. So we've got an x squared, negative 1 plus 2, or 2 minus 1, whichever way you look at it is, plus x minus 2. All right, so that's my product of the first 2. And then we're going to take that and multiply by x plus 3. Now, Up until now, we've had a 2 by 2. Because we've had 2 terms in the first parentheses and 2 terms in the last parentheses. However, in the first parentheses, how many terms we got? We got 3. And how many on the last one? 2. So now we need to make a box that's a 3 by 2. Okay? So we're going to have 3 rows. 3 columns. And how many rows? 2. And it's going to work the exact same way. So across the top, x squared plus x minus 2. And on the side, x plus 3. Solve it like normal. Ian, what is x squared times x?
X cubed.
X cubed. All right, and then we have x times x, which is what, Callie? X squared. And negative 2 times x, which is what, Kyler?
Negative 2x.
Negative 2x. And then on the bottom, Dylan, we have x squared times 3, which is 3x squared. And then we have 3 times x, which is 3x. And then TR, we have 3 times negative 2, which is negative 6. Now, do we have things we can combine? Yes. Do we have another x cubed besides that one that's there? Nope. So let's just write it. X cubed. Then we got a 3x squared and another x squared, which makes 4x squared. And then do we have another x term besides the 3? Oh, I forgot to add it. Sorry. So a 3x minus the 2x is just a x and minus 6. So here, once again, how many first degree polynomials did I start with? Started with 3. And then I ended with 1 third degree. Okay, so you see how it kind of just flip-flops? Whatever you start with is the opposite of what you end with. Okay? We'll finish up this section, SAS 2, and then we'll start SAS 3 also on Monday because it's only 4 pages. It won't take us very long. Okay?